1.4 Estimating Surds. So our South African book has a couple different things in there, or things that are different from what you're used to, and one of them is the word surd. That's their expression for radical or root. If we're dealing with square roots, which we are in the first two examples, then you should be able to find a good estimate for a square root by looking for two numbers that are a perfect square. I'll explain a little bit through the example. So, for example, the square root of 4, you know that that's 2. You know that the square root of 9 is 3. So I don't know what the square root of 5 is, but I do know that it has to be between 2 and 3. Okay, it's got to be a little bit more than 2. It has to be less than 3. Now, the book will ask you to find the two integers between which the square root is. I think you need to be able to do a little better than that. So let's put 2.5 in here. That's the halfway point. And then just look, is 5 closer to 4 or to 9? Well, 5 is clearly closer to 4. So since it's closer to 4, my estimate needs to be between 2 and 2.5. So if you told me that the estimate for the square root of 5 that you came up with is 2.2, and then showed me this work, then that would be reasonable. 2.1 would be fine. I actually probably still give you credit for 2.3. At 2.4, I would probably start deducting maybe a little bit, because you're really close to 4. Let's see, the square root of 173. Well, the square root of 169 is 13, and the square root of 196 is 14. So we are again between two whole numbers. I'm going to put 13.5 in the middle. And then from 169 to 173 is only a step of 4. And from 173 to 196, that's actually 23 more. So I think that the square root of 173 is really close to 13. So in this case, let's try 13.1. If you wrote 13.2, that would be fine again. You shouldn't write 13 here. Although the bigger the number you are and the closer you are, like the square root of 170, if you wrote that that's 13.0, I would give you credit. Okay, then the next one. Now, notice here there's a little index here. So the 4 is called an index, and the index tells you what root you are looking at. So this is the 4th root. That means that you're not looking for a number that squares, because this really has a 2 in there that you don't see. So we're not looking for 13 times 13 is 169. We're looking for a number that, so clearly not 10 times 10, for example, because 10 times 10 is 100, times 10 is 1,000 times 10. So this is not going to give me 10. I'm looking for a number much smaller than that. So if you're not sure where to start, you just pick a number that you think might be close. So for example, if I did 2 times 2 times 2 times 2, 4 times 4 is 16. Well, that's less than 100. So let's see what happens at 3. So 3 times 3 times 3 times 3. So 9 times 9 is 81. So I'm pretty close to 100. Okay, so I don't need this one. I should not have even guessed that. And then I'm pretty confident that at 4 I will be past 100. Okay, because 4 times 4 is 16. So this is really 16 squared, which is 256. So then we can say that the 4th root of 81 is 3, and the 4th root of not 100, I'm sorry, 256. We know that that is 4. I'm going to put 3.5 in the middle, and I'm going to do the same thing. 100 is closer to 81 than it is to 256. It's actually a good deal closer to 81 than 256, so, maybe it's 3.2, maybe it's 3.1, maybe it's 3.3. I give credit for all of those, okay? So you should be able to estimate surds by using whole numbers. And a quick little review of, what do products look like with variables. And you should be able to identify some vocabulary that's tied to something like this. So this 3x squared plus 7xy minus 5 cubed equals 0. Okay, a term is any of these parts. So this one has 3x squared is a term, 7xy is a term, the negative 5 cubed is a term, and 0 is a term in this equation. Okay, so might as well put that over here then. So that is what goes over here. So an equation is something that has an equal sign. If you don't have an equal sign, we just call it an expression. So on the left side, the expression is this. And on the right side of the equation sign, we have 0 as an expression. Coefficient refers to the numbers in front of variables. So 3 is a coefficient. 7 is a coefficient. Generally speaking, we wouldn't call this -5 a coefficient. An exponent is a number that's on top of a variable, or a number, but that's an exponent. So 2 is an exponent. Both the x and the y have an exponent of 1. So we do have an exponent of 1 here. And then the 3 is an exponent for the base of 5. And I just used the word base. So base is the expression that is at the bottom here. So the base of x, we have a base of y, and we have a base of, and I would say 5 here is the base. And we could argue about that a little bit, but it's probably safer to just use a positive number here as a base. Right, constant. So a constant is something that doesn't change. So the only value that doesn't change here is the -5 cubed, because the -5 cubed is always 100 and -125. And then a variable is something that's sort of a placeholder. It's a symbol that stands for multiple values. So x and y are the variables we have. Now you do need to know a monomial, a binomial, and trinomial. So if I say monomial, you should be thinking of a one-term expression. For example, 2x only has one term. They can be way more complicated. This only has one term. It has a bunch of stuff in there, right? But one term. A binomial has two terms. So 2x plus 1 would be a binomial. 5a minus b squared would be a binomial. A trinomial is something that has three terms. A very common looking trinomial would be this, and we'll deal with this pretty quickly, or pretty soon in the year. But, you know, it's anything that has three terms, so this would also be a trinomial. Okay, polynomials, that's the catch-all phrase for all, like one term, two term, three terms, four terms, five, etc., etc., can be multiplied. So a monomial and a binomial would look something like this. X squared times, for example, x plus 3. And I just call this distributing. So distributing means to multiply across. So I say distribute is multiply across your terms. So if you do that, you get x squared times x. Keep in mind that has an x to the first, so that makes it an x cubed. And x squared times 3 is 3x squared. When you have two binomials, then people usually say, well, then you're going to FOIL. Now, I don't particularly like FOIL as an expression because it only works for binomial times binomial. So I'm still going to call this distribute. But FOIL stands for first. That would be the first term times the first. The O stands for the two outer terms. So that's what we're going to do next. So that's an outer term and that's an outer. They're both on the outside. And then the I stands for the two inner terms. That would be when you multiply this negative b and that 2a. And then L stands for the two last terms. So the last in the first binomial and the last in the second binomial. And that's the pattern. So I think of this as this a needs to multiply and the 2a and the 5b. Well, a times 2a is 2a squared. A times 5b is plus 5ab. And then we do a negative b times 2a. That's a negative 2, and I'm going to write it in alphabetical order right away. And I'm sort of going to line it up as I go. And then a negative b times a positive 5b is a negative 5b squared. And the reason I line it up as I go is because it's easier to see that I do need to add these two terms. So 5 minus 2 is 3. So that's plus 3ab minus 5b squared. Okay. And then the last would be a binomial and a trinomial. So I'm going to use a fairly traditional looking problem for that. Okay, so vocabulary, I would still, let's make that a negative 4x. So that's what I have in my notes. In my vocabulary, I still am going to say distribute here. So over here I said this a needs to multiply the first and the second term here. So this x needs to multiply this x squared, needs to multiply that negative 4x, and it needs to multiply that 4. So let's do that. So x times x squared is x cubed. X times a negative 4x is a negative 4x squared, and x times 4 is plus 4x. Then this 3 needs to multiply that x squared, that negative 4x, and that 4. So plus 3x squared, and again, I'm going to line things up as I go. And 3 times a negative 4 is minus 12, and then an x. And 3 times 4 is 12. And then you add things that belong together, so the x cubed doesn't have anything to combine with, but a negative 4x squared plus 3x squared would be minus 1x squared. So we usually drop the 1 then. And then 4 minus 12 is a negative 8x, and then the 12 is on its own. So then your final answer looks like this. Thanks.